All right, hello everyone. I don't know when you're watching this, but this is Monday's lesson. So we're going to be starting chapter 4. The tests are all taken care of, and let's move on. So 411 today, we're going to review how to write equations and use them to solve problems. You will need some graph paper, colored pencils, and a pencil for today's lesson. We're going to do 4.1 to 4.3. Your homework is going to actually be problem 4.4. So we're not going to have review preview homework. Even though this is a 2-day lesson, what Miss Smith and I decided is we're going to kind of summarize the review preview into 1 day. So your task, your homework for today is to do problem 4.4. That's going to take a little bit of time, but it's doable. It should be fairly straightforward. You should be able to get that done in a reasonable amount of time, okay? And then on Tuesday, there's no school, okay? And then Wednesday, we will finish lesson 4.1.1, and we'll summarize our the review preview. We'll combine it into 1 day. Got it? So 4.1.1, how can I use variables to solve problems? Solving word problems by writing equations. Chapter 4 is about systems of equations. Now, we have done, chapter 3 was kind of a summary of reviewing, solving equations, and hopefully you feel comfortable doing that. Now we're going to take that to the next level. So this chapter is going to be some intense algebra. And it's going to be kind of challenging if you are sloppy. So this chapter, I really want you to focus on neatness and showing work in an organized, structured, clear way. Got it? But today, solving word problems by writing equations. Today, you will learn to translate written information into algebraic symbols and then solve the equations that represent the relationships. And here's our first problem. 4.1, you are going to match each equation or each sentence on the left with its translation on the right. Okay, well, actually, each sentence here, okay, matches one of these equations down here. Now, the problem is, there we go. I can fit them in there, just barely. Let me see if I can make it a little bit smaller here so you can see it. Here are the equations, and they are a doozy. This is actually kind of a challenging problem set here, okay? So I want you to pause the video and see if you can match one of these numbers. So 1, 2, 3, and 4. So on your paper, you're going to have 3.1.1 and 1, 2, 3, 4, and match them with these 4 letters, A, B, C, and D. Which one is which? Got it? You should get this done in about 3 minutes, okay? So pause the video. You got 3 minutes to do this. Got it? Go. All right. If you pause the video and you did this, you realize this is kind of tricky, isn't it? Because, you're like, Z, that's no problem. Well, all of them have Z, like Zola and zinc and what's the other one? Zoo and Zach. All of those are kind of confusing. So you can't base it on the variable. You really got to notice the information. And if you got it right, you should have gotten that. Number 1 was letter C. Number 2 was letter A. Number 3 was letter D. And number 4 was letter B. Okay? So if you match them correctly, that's how it should go. And there were some key words there that hopefully kind of made you see that and kind of, okay, I see the connection. Hopefully that matched up and you were good. Okay? Cool. Problem 4.2 now. Mathematical sentences like those in the left column of problem 4.1 are easier to understand when everyone knows what the variables represent. A statement that describes what a variable represents is called let statements. This is going to be huge. We're going to be talking about this a lot. For example, for the mathematical sentence above, for A, which is matched with translation 2, we could say let Z equal Zola's rate of pay in dollars per hour. Note that a let statement always indicates the units of measurements. Okay? So right now, I want you to go back and write a let statement for each of the mathematical sentences in parts B through D above. So the first one's is there right there for us. For number 1, let Z equal. And so anytime we write sentences from now on, anytime we write equations from now on that use variables for word problems, we need to write a let statement. Okay? Let statement. And we say let whatever variable equal what it is, and then how we are measuring it goes in parentheses, okay? So instead of saying how many Zola's dollars per hour, we say her rate of pay. That's what we're measuring, the rate of pay. How are we measuring it? In dollars per hour. Got it? In parentheses, you put the unit of measurement. Okay, so go back here and I want you to now focus on number 1, the zoo, number 3, the ounces of zinc here, and number 4, the pay, okay? Write a sentence now, that statement for all 4 of those, or all 3 of those. Okay, I didn't tell you to pause, hopefully you paused, but let's go for it. Talking about let's go with this last one, and it really doesn't matter, we'll just go from here. Let's talk about this one. So in this case, it's let z equal, all right, let z equal the amount of time Zach worked. Yikes. And then in parentheses, how are we measuring that? We're measuring that in hours. Okay, so z was the amount of time that Zach worked in hours. All right. Now, let's go to this top one here. The top one. This is let z equal the amount of zebras in the zoo. Okay, and in this case, we are going to say we are just count. Count is when we just count the numbers, where it's not really zebras, it's count. We put that, okay? And I know that's a little bit different. It's difficult because they don't really have units, so anytime you're just saying how many there are of something, since you say amount of zebras, you can just say count. By the way, please be specific. Don't say let z equal zebras. That's not going to fly. You do that, I am going to take points off. You have to be specific. Let z equal the amount of zebras in the zoo. So based on that, then looking at number 2, where we're talking about, number 3, where we're talking about zinc. Again, it's not let z equal zinc. It's let z equal what? Oh, careful with this one. This one is let z equal the weight of the zinc. And then in parentheses, in ounces. Do you see that? We're measuring the weight. We're not measuring the ounces. We're measuring the weight in ounces. Cool? So let statements, I do need you to pause and think about let statements as you're working on them. Anytime you create an equation from a word problem and you pick some variables, you're always going to write let statements. And they should be fairly specific, saying what the variable is, what it measures, and then what unit it measures in. Got it? Some of you are going to try to shortchange me, and I'm telling you it's not going to work. So you don't need to write a paragraph, but don't you dare say let z equals zinc or let z equals zebras. That's not going to be enough, okay? All right, number 4.3. Perimeter of a triangle is 31 centimeters. Sides 1 and 2 have equal length, while side 3 is 1 centimeter shorter than twice the length of side 1. Let's determine how long each side is. So first of all, let x represent the side length of side 1. What essential part of this let statement is missing? What do you think? What essential part of that statement is missing? All right, what it's missing is the unit of measurement. So it should say in centimeters, okay? Let x represent the length of side 1 in centimeters. That's what it's missing there. And then it's saying, what do we know about side 2 and side 3? What that means is, based on that, well, side 1 is x. Side 2 would be what? Okay, so side 2 should be x. And side 3, oh, this one's a little tricky here. Side 3 is what? It's 1 centimeter shorter than twice the length of side 1, so it should be 2x minus 1. 2x minus 1. Got it? All right, so now letter B, write a mathematical sentence that states the perimeter, that the perimeter is 31 centimeters. So take a second, please. Write me a sentence that shows that the perimeter is 71 centimeters mathematically, okay? I know that's a little weird in the way they said it, but here's what they meant. They said like side 1, which is x, plus side 2, which is x, plus side 3, which is 2x minus 1, equals 31. When they say a mathematical sentence, that's what they're referring to. It's a combination of numbers and letters that mean something. mathematically, okay? And last but not least, solve the equation you found in part B. B, and determine the length of each side. Be sure to label your answer with the appropriate units. So you should have, when you had that, x plus 2x minus 1 equals 31. I add those up and get 4x minus 1 equals 31, plus 1, divide by 4, x equals 8. Now, here's the thing. At that point, we need to label, okay? So, determine the length of each side. So then I have to just go, okay, side 1, and we could say side 1 and 2 are 8 centimeters, okay, long. And then side 3 would be, well, 1 less than 2 times. So 2 times 8 would be 16, minus 1 would be 15 centimeters long. Got it? So make sure you answer the questions they're asking you for. Okay, good. Last but not least, problem 4.4. The environmental club. Charles and Amy are part of the environmental club at school. Their service project for this semester is to get a tree for their school donated and planted on the school grounds. Charles' uncle owns a tree nursery and is willing to donate a 3-foot-tall tree that he says will grow 1.5 feet per year. Amy goes to another nursery in town, but is only able to get a tree seeds donated. According to the seed package, the tree will grow 1 7/500 feet per year. Charles plants his tree and Amy plants a seed on the same day. Amy thinks that even though her tree will be much shorter than Charles' tree for the first several years, it will eventually be taller as it grows more each year. But she does not know how many years it will take for her tree to get as tall as Charles' tree. Will the trees ever be the same size? If so, how many years will it take? Okay, so that's the problem. And you look at the information there, because what you are going to do is you, for homework, are going to answer this problem. And we are going to address this problem in class on Wednesday, so you must have this information and you must have it done accurately. Here's what you're going to do. Your task. Represent this problem with tables, equations, and one graph, okay? Tables, equation, and one graph. All right, so I expect to see one table for each tree, one equation for each tree, and one graph on which both trees are on. And if you saw my list of materials, I did say colored pencils, hint, hint, nudge, nudge. You should have that. Use each representation to find the solution. Explain how you found the solution in each of the 3 representations. What solution are we talking about? When the 2 trees are going to be the same height. So, discussion points. How can the given information be represented with equations? What is a solution to a 2-variable equation? How can this problem be represented on one graph? And how does the solution appear on the graph? So that is your task. That's what you're going to do, okay? I am going to go to this just because it's funny and I like it anyway. So you can pause the video here and read it. Otherwise, in 5 seconds, I'm going to move back. Okay. So I'm going to go back now, and here's what I'm going to do. Again, I'm going to leave this information. You might want to write down the information. And at this point, you are going to probably have to either go to your book and follow this information, or you're going to pause the video at different parts. Here's the basic information here, and here is your task of what you're going to do. Got it? This is due by, do I want you to upload a video today? Yeah, I really want you to upload a video by midnight tonight, please. Actually, I'll give you till tomorrow, Tuesday at midnight, to get this video uploaded, this picture uploaded of your work for problem 4.4. On Wednesday, we will finish up and discussing this problem. Got it? All right, ladies and gentlemen, hope you have a wonderful weekend. Enjoy your time, enjoy your day off, and we'll see you on Wednesday.